Okay, students, good morning to all of you. Myself is Dr. Santosh Choudhury, reader in chemistry. And in class number 4, we will discuss some characteristics of alcohols. The characteristics of alcohol due to the cleavage of oxygen hydrogen bond and the cleavage of carbon oxygen bond. And we will discuss the dehydration of alcohols. The alcohol dehydrate to form corresponding alkene by losing a molecule of water in presence of suitable dehydrating agent. Lastly, we discuss the reaction of alcohols, in particular ethanol, with the concentrated sulfuric acid. The ethanol react with sulfuric acid at different temperature to give different product. That is, at low temperature it gives ethyl hydrogen sulfate. At little high temperature, in presence of excess of alcohols, it gives diethyl ether. And till higher temperature, in presence of concentrated sulfuric acid and excess of sulfuric acid, which is a strong reacting agent, it can form the ethene. Today we will discuss some other characteristics of alcohols, that is your oxidation. You know, oxidation means addition of oxygen. And the oxidation taking place in presence of some oxidizing agent. And the oxidizing agent for alcohol are alkaline, KMnO4, acidified, KMnO4, acidified K2Cr2 potassium dichromate, or you can take concentrated nitric acid. These are the oxidizing agent used for the oxidation of alcohols. And the different alcohols means primary, secondary, tertiary give different oxidation product. From the oxidation product of alcohol, we can identify the primary, secondary, tertiary alcohol. That means by the oxidation method, we can identify the primary, secondary, tertiary alcohol. So let us see oxidation of primary alcohol. You know what is primary alcohol? That is, first come to oxidation of primary alcohol. What is this primary alcohol? That is RCH2OH is known as primary alcohol. When the primary alcohol is treated with oxidizing agent like acidified potassium dichromate, the carbon is get oxidized. It gives you the oxidized to give OH. One OH will be there, and another hydrogen oxidized gives two OH. And it is unstable, it got lost molecular water. So it gives you C, it lost molecular water, that is CH double bond. This gives you aldehyde. And aldehyde further oxidized, this H is oxidized, this H, it became carboxylic acid. So we can say the primary alcohol oxidized to a aldehyde, which further can oxidize to a carboxylic acid. And this carboxylic acid, the final product, that possesses the same numbers of carbon atom as in the alcohol. What alcohol? The primary alcohol. So this reaction can be controlled at this step. This reaction control up to aldehyde. Reaction up to control up to aldehyde. Controlled oxidation by using some other oxidizing agent that is called Corres reagent. The Corres reagents are PCC, PDC, Collins reagent. That means when primary alcohol treated with any Corres reagent means PCC, PDC, Collins reagent, the primary alcohol only oxidized to aldehyde, not to carboxylic acid, and this will discuss in your method of preparation of aldehyde and ketone from alcohol. Okay, let us see, you take any particular primary alcohols. What you learn here, you see the primary alcohol group is oxidized to an aldehyde, and the aldehyde is further oxidized to a carboxylic acid. Suppose I will take RCH2OH. This is your primary alcohol. This is oxidized by acidified potassium dichromate, and this group will be oxidized to an aldehyde group, RCHO. This became aldehyde. And this aldehyde further oxidized because you are using acidified potassium dichromate. The reaction is not controlled. It gives you R, and this is your carboxylic acid. So, any primary alcohol first oxidized to an aldehyde and the further oxidized to a carboxylic acid. Suppose you take ethanol. How many carbon atom? The ethanol contains 2 carbon atom. This is your ethanol, an oxidation with acidified K2Cr2O7. This group, the CH2OH group, is oxidized to an aldehyde, that is CH3CHO. This gives you ethanol. Ethanol oxidation gives you ethanoic acid. That means any sample of the alcohol, the sample may be primary, secondary, any sample of the alcohol when treated with acidified potassium dichromate solution, which is orange in color, and it immediately turns to green, and the alcohol is oxidized to the final product of the sample is a carboxylic acid, and that carboxylic acid containing same number of carbon atom, then the sample of alcohol is said to be primary alcohol. And you see this alcohol containing 2 number of carbon atom, and the carboxylic acid also containing 2 number of carbon atom. And this is the oxidation of primary alcohol. Okay, next come to what about the oxidation of Now come to the oxidation of secondary alcohol. What is the secondary alcohol? Secondary alcohol containing the two alkyl group bonded with carbon atom and that have OH group. This is your secondary alcohol. This is upon oxidation by action of acidified K2Cr2O7. The OH group bonded to carbon atom, and that carbon atom is one hydrogen atom, and that hydrogen atom gets oxidized to OH. That means the carbon is now oxidized to form OH. OH, this is your unstable, and this get lost molecular water. It gives a carbonyl group compound. This is your ketone, and this will now more oxidation because there is no any oxidizable hydrogen atom possessed by the carbon atom. That means the secondary alcohol is oxidized to a ketone and possesses same number of carbon atom. This ketone has same numbers of carbon atom as in the alcohol. So what do you learn? This is secondary alcoholic group. An oxidation gives a ketone. So, if you take any secondary alcohol, suppose this is your RRCHOH, this is your secondary alcohol. This is an oxidation with acidified K2Cr2O7. This is the result to give a hot ketone, and this ketone possesses the same number of carbon atom as in the alcohol. Suppose you take propanol 2. Suppose you take propanol 2. This is your CS3 CHOH CS3. This is your propane 2OL. An oxidation with acidified K2Cr2O7 and the second alkyl group, that is CHOH group, get oxidized to form the ketone, and this is your propanol. Okay, students. So any secondary alcohol, an oxidation gives a ketone, and the ketone possesses same number of carbon atom as in alcohol. You see this propanol 2 is a secondary alcohol containing 1, 2, 3 numbers of carbon atom, and the propanol means acetone also have 3 numbers of carbon atom. And the same oxidation can also be carried out by a specific reagent, that is your, suppose you take RCHOH. This is your secondary alcohol, and this is treated with isopropyl aluminum isopropyl butyl oxide. Isopropyl oxide. What is that one? This is your CH3 whole twice CHO. This is your isopropyl oxide. Isopropyl means the branching chain. That means CH3, CH, CH3. This is called isopropyl alcohol, and this is called isopropyl oxide. When I write this will come to whole twice O minus. So this one, and this will react with your aluminum. Means aluminum valence is 3. This is called aluminum isopropyl oxide, and you take the solvent is your acetone, and the secondary alcohol is oxidized to a ketone, and this reaction is known as Opnier oxidation. Opnier oxidation. And you can also read in the preparation of acetone or preparation of ketone in aldehyde and ketone chapter. So our conclusion is the secondary alcohol is oxidized to give a ketone. Secondary alcohol oxidized to give a ketone, and the ketone possesses the same number of carbon atom as in the alcohol. Okay, students. Next come to what about the oxidation of tertiary alcohol. You know the tertiary alcohol oxidation. Tertiary alcohol. What is tertiary alcohol? And the tertiary alcohol, the carbon atom possesses the OH group, and there is no more hydrogen for oxidation. That's why when I treated with acid 5 K2Cr2O7 does not oxidize because the carbon does not have any oxidizable carbon atom. This is carbon-carbon bond. This is a carbon-carbon, because another alkyl is there, and this is also carbon-carbon bond. And the carbon-carbon bond somewhat stronger than the carbon-hydrogen bond. That's why carbon-carbon bond cannot be oxidized as easily as in case of carbon-hydrogen bond. That's why the tertiary alcohol does not oxidize easily. But on drastic condition, drastic condition we are using hot KMnO4 or concentrated nitric acid. Then the tertiary alcohol is oxidized to form the mixture of ketone and carboxylic acid. And individual ketone and individual carboxylic acid possesses less number of carbon atom as possessed by the alcohol. That means on drastic oxidation, the carbon-carbon bond somewhere break. That's why on breaking, on drastic oxidation, the tertiary alcohol on drastic oxidation using hot acid 5 KMnO4. This will give the mixture of, suppose this is your CH3 group, mixture of ketone plus formic acid. This is your mixture of ketone plus carboxylic acid, and these are possesses less the less numbers of carbon as compared to alcohol. Okay. So, suppose you take a tertiary butyl alcohol. Suppose you take a tertiary butyl alcohols. Which are oxidizing, what product gives? The tertiary butyl alcohol, that is your CS3C, CS3, CS3OH. This is your tertiary butyl alcohol. This is an drastic oxidation, that is concentrated. Suppose nitric acid are taken and this one of the alkyl bond is break here, it result from CS3, C double bond O, CS3 plus HOH. This is your a ketone, that is called propanol. So you see, the alcohol and oxidation gives the different product. The primary alcohol gives some product other than the oxidation product of secondary alcohol, and the secondary alcohol gives different product, the oxidation of tertiary alcohol. So you can say this one of the identification of alcohol, whether the sample of the alcohol is primary, secondary or tertiary. So you conclude that suppose you take the sample of alcohol, you don't know whether it is a primary, secondary or what, tertiary, and this alcohol is treated with acidified potassium dichromate. So if it gives the carboxylic acid, then it is primary alcohol. Sample is your primary alcohol. If it gives a ketone, then the sample is your secondary alcohol. If it does not oxidize easily on drastic condition, it gives the mixture of ketone and carboxylic acid, which are possesses less number of carbon atoms than the alcohol, then the sample said to be tertiary alcohol. And these are possesses same numbers of carbon atoms as in the alcohol. So we can identify the sample, whether the sample of alcohol is primary, secondary, tertiary, by the process of oxidation by putting some oxidizing agent like acid by potassium dichromate. You know, the color of the acid by potassium dichromate is an orange color. It when on redox, when it oxidizes to other, its color changes to green color. If the color of the orange color of the potassium dichromate changes to green and result to form a carboxylic acid, possesses same number of carbon atom, the sample of the alcohol is your primary. If the color of the acid by potassium dichromate solution changes to green and the product give a ketone which possesses the same number of carbon atom, then the sample is said to be secondary alcohol. If under condition, if the orange color of perfume dichromate does not change, then we can say the sample of alcohol is what? Tertiary in nature. Okay, student, this is the one of the way the oxidation of primary, secondary, tertiary alcohol. And now comes another one, that is your another method that's called oxidation, means adds an oxygen. Another method is removal of hydrogen, that is called dehydrogenation of alcohols. Dehydrogenation means loss of hydrogen. So here also the sample may be primary, secondary, tertiary. When the primary alcohol on dehydrogenation, it gives an aldehyde. The secondary alcohol on dehydration gives a ketone. And the tertiary alcohol on dehydration gives a isoalkene. Just you see in method preparation, the ketones, aldehyde ketone reduced to primary, secondary alcohol. Here the primary alcohol and secondary alcohol dehydrates. Dehydrogenation means by losing the molecular water corresponding aldehyde and ketone. Suppose you take a primary alcohol. What is primary alcohol? That is, this is RCH2OH. You can say this is your primary alcohol. Suppose I write this primary alcohol, that is CH2 group like this one. And this is passed over the red hot copper. You see copper foil, तंबा copper foil को hit करे red है जीवो, ताकि red hot copper. A red hot copper is the function to remove the hydrogen from the molecule. It can absorb hydrogen. Yeah, that's why the red hot copper at 300 degrees C. This alcohol lost a molecule of hydrogen. How it is? This is your hydrogen and this hydrogen. It get lost. And this bond became C double bond O. So this became RCHO plus H2. This is your respect to aldehyde. So any primary alcohol passed over the red hot copper, it dehydrogenation to form the corresponding aldehyde, and that aldehyde possesses the same number of carbon atom is in the alcohol. Suppose what you learn here, that is, you see CH2OH group on passing red hot copper at 300 degrees C, this will changes to what? CH. Just like your oxidation. You see, in oxidation means addition of oxygen or removal of hydrogen. This one, you remove this hydrogen. Suppose you take ethanol. What is ethanol? What is ethanol? That is, the ethanol is this is your ethanol. And this ethanol passed over the red hot copper at 300 degrees C. And this is your primary alcoholic group. Would get changes to CH3 CHO plus hydrogen. This is your ethanol or acetaldehyde. So any primary alcohol, when passed over red hot copper at 300 degrees C, it get lost molecule of hydrogen to form the corresponding aldehyde. Now come to what about the dehydration of secondary alcohol. The secondary alcohol means this is your secondary alcohol, and the secondary alcohol passed over red hot copper at 300 degrees C, it get lost molecular hydrogen. So what will happen? This became a double bond. So this became C double bond O plus H2. This is your ketone. That means I will write this one in this way. It will be easy to you. And this is your hydrogen, and this is your OH group, and it get lost molecular hydrogen. This bond became double. This became what? Ketone. So any secondary alcohol pass over red hot copper at 300 degrees C, it get lost molecular hydrogen, it became a ketone. Suppose you take a propanol 2, this pass over red hot copper at 300 degrees C. What product you get? This is your second alcoholic group, CHOH group. And the CHOH group will changes to what? A keto group, that CH3, C double bond O, CH3 plus H2. This is your ketone, that is called acetone or propanol. So any secondary alcohol, any sample of secondary alcohol passed over red hot copper at 300 degrees C, it dehydrogenate to form the corresponding ketone, means it possesses same number of carbon atom. Now we come to what about the tertiary alcohols. You see, the tertiary alcohols are different. The tertiary alcohol that is the carbon atom possesses 3 alkyl group, and the carbon atom does not have any hydrogen like primary or secondary alcohol. This is when passed over red hot copper at 300 degrees C, it undergoes dehydration. It undergoes what? Dehydration means loss of water, not hydrogen, loss of here water. How is the water loss? And this OH group and this H from the alkyl group, this will come to here. Otherwise, this will bond go to here. It will form C double bond CH2 plus H2. This is your isoalkene. So the tertiary alcohol the tertiary alcohol passed over red hot copper 300 degrees C, it undergoes dehydration to form corresponding isoalkene, means branched chain alkene. Suppose you take tertiary butyl alcohol, or you can say 2-methyl propane 2-OL. This is tertiary butyl alcohol or a tertiary alcohol when passed over red hot copper at 300 degrees C. What it gives? This will gives this OH, this is H, and this bond come to here. It will go to there. It became CH3, CH3, double bond, CH2 plus H2. This is called iso. Sorry, we will write APEC name. The APEC name is 2-methyl propene. What is that one? 2-methyl propene. So we can say isobutene or butylene. Isobutylene. So hence we can also identify the primary, tertiary, secondary, tertiary alcohol by passing over the red hot copper at 300 degrees C. The primary alcohol gives you an aldehyde, the secondary alcohol gives you a ketone, and the tertiary alcohol gives the isoalkene. Corresponding means there is no change in what carbon atom. So suppose you take the sample of alcohol. You does not know whether it is primary, secondary or tertiary, and the sample of the alcohol now pass over red hot copper at about 300 degrees C. If it gives an aldehyde, then the sample is your sample aldehyde. You can write this sample. This is your product. The product is aldehyde, the sample is your primary alcohol. If the sample is your ketone, then if the product is your ketone, then the sample is your secondary alcohol. If the sample is your isoalkene and this sample is your tertiary alcohol. You see, you can nicely identify the primary, secondary and tertiary alcohols by passing over red hot copper at 300 degrees C. If the product is aldehyde, the sample is primary. If the product is a ketone, possesses the same number of carbon atom, the sample is secondary. If the product is not a aldehyde, not a ketone, rather it is a isoalkene, then the sample is called tertiary alcohol. Okay, these are the oxidation of alcohols by two methods. One method is addition of oxygen by using some oxidizing agent. Another method is removal of hydrogen by passing over red hot copper. By the oxidation, we can identify the primary, secondary, tertiary alcohols. And same thing will be repeated during the preparation of aldehyde ketone from alcohols by oxidation or by dehydrogenation. The primary alcohol oxidation gives you an aldehyde by using some specific oxidizing agent, and secondary alcohol and oxidation gives a. Okay, students. Now we come to how can you identify what the test of primary and secondary tertiary alcohol. That is test or identification test of primary, secondary, tertiary alcohol. Test means you put the reagent, you get the result. That's called test. So how can you test the sample is given, sample is primary, secondary, tertiary alcohol? You can identify the sample as primary, secondary alcohol can be tested by oxidation method. Second is called dehydrogenation method, means loss of hydrogen. Another method we have already taught to you, that is what it's called Lucas test. Another method is your Victor Merc test. We have already discussed the oxidation, dehydration. You also discussed about the Victor Merc test. Again, I repeat to the Victor Merc test. The Victor Merc test means you are using the Lucas test means you are using the Lucas reagent. Okay? Suppose you take the sample of alcohol. The sample may be primary, may be secondary, may be tertiary. You may arise a question in your mind, sir, primary means CH2OH group, secondary means CHOH group, and tertiary means COH group. If that, then you can. So first you know where the sample means just like water, there is no structures. To the sample we have to identify whether it is primary, secondary or tertiary. In this case, the sample is treated with Lucas reagent. What is Lucas reagent? Lucas reagent is your concentrated HCl plus anhydrous zinc chloride. And the alcohols react with the Lucas reagent to form the corresponding alkyl chlorides. And the alkyl chlorides are from the turbidity. And the rate of formation of turbidity that can be identified the primary, secondary, tertiary alcohols. The reaction of alcohol towards the Lucas reagent, the order is tertiary is more reactive than secondary, is more reactive than primary. So, if the product form the turbidity, do you know turbidity? White precipitate. Form the turbidity immediately, then the sample is tertiary alcohol. That means when the sample treated with Lucas reagent, it gives the turbidity immediately. Then we can say the given sample is your tertiary in nature or tertiary alcohol. When it forms the turbidity, on standing for 5 minutes, then the sample is your secondary alcohol. Why? Because the towards Lucas reagent, tertiary alcohol is more reactive than the secondary. That's why after 5 minutes it forms the turbidity. If the turbidity does not form even after 5 minutes and it forms the turbidity on heating, it forms the turbidity on heating, the sample is your primary alcohol. So if the sample may be primary, secondary or tertiary, can easily identify by the action of Lucas reagent. This is called what test? Lucas test. So Lucas test is used for the identification of primary, secondary and tertiary alcohols. Okay students, now come to another test that is called Victor-Merc test. And the Victor-Merc test, you take a certain steps of reaction. That is, in Victor-Merc test you take the sample of alcohol. So I will write here first. This is your Victor-Merc test. In Victor-Merc test, you take the sample of alcohol. You don't know whether it's primary, secondary or tertiary. Now the sample of alcohol is treated with red phosphorus plus iodine. You know, when the alcohol treated red phosphorus iodine, it forms some iodide and it forms product, or it forms iodide, and this iodide treated with AgNO2, it forms nitro compound, and this nitro compound treated with nitrous acid, and nitrous acid, it gives some acid that's called nitrolic acid, and this is treated with NaOH. If sample gives, that is, after this treatment it gives you blood red coloration, the sample is your primary alcohol. If after this treatment, series of treatment means first you treated with that plus iodine, then AgNO2, then HNO2, then NaOH. If it gives you blood red coloration, then sample is your primary alcohol. And if it gives a blue coloration, then the sample is your secondary alcohol. If it does not give any color, then the sample is your tertiary. That means the sample on Victor-Merc test gives a blood red coloration, then the sample is your primary. If it gives a blue coloration, then the sample is your secondary. If it doesn't give any color, the sample is your tertiary. It is called a Victor-Merc test. And how the reaction is carried out, how the primary alcohol gives the blood red coloration and secondary alcohol gives a blue coloration, and the tertiary alcohol gives a what? Does not give any coloration. So students, let us start with primary alcohol. The primary alcohol means RCH2OH. This primary alcohol treated with red phosphorus plus iodine, it forms RCH2I. This is treated with AgNO2. These are the steps for Victor-Merc reaction or Victor-Merc test. It gives RCH2NO2. This is treated with HNO2. It gives you RC double bond NOH, and NO2, this is called nitrolic acid. This is treated with NaOH. This gives you blood red coloration. So when treated the red phosphorus and I, it gives Bi3, this OH group become I, and the alkyl iodide treated AgNO2 is nitroalkanes. This nitroalkane treated with nitrous acid. This is your what acid? Nitrous acid. It gives some nitrolic acid. What it called it is? This part is called nitrolic acid. Alkyl nitrolic acid, which are alkaline with NaOH, it gives the blood red coloration. And what about this secondary alcohol? What is the secondary alcohol? RCHOH. This is our secondary alcohol. The secondary alcohol treated with red phosphorus plus iodine. It gives what? The OH became I. It gives you RCHI. This is treated with AgNO2. This is RCHNO2. When treated with HNO2, and HNO structure HON double bond O. So the HO plus this one, it is RCR bond N double bond O. This is your NO2. And this is called not a nitrolic acid, it's called pseudo nitro. This is upon treated with NaOH. This is gives you blue coloration. You see the difference of reaction here. Different reaction here. That's why it gives two different coloration. One gives you blood red coloration, while other gives you blue coloration. Next, what about the tertiary alcohol? That is tertiary alcohol. That is R. This is tertiary alcohol, or you can write this in this way also. Sorry. This is your tertiary alcohol when treated with red phosphorus plus iodine. This OH group I, and this I treated with AgNO2. This became NO2, and this I treated with HNO2 does not react. Why it does not react? Because the carbon atom does not have any more hydrogen. That's why this product, that is tertiary alkyl nitrate, nitro tertiary does not react with HNO2 because there is no hydrogen. As it does not react, so does not have any color. It does not have any color. Okay, students, this is called a Victor-Meyer test. When the sample of the alcohol undergoes Victor-Meyer reactions, that is treated with red phosphorus plus iodine, then NO2, then HNO2, then alkaline with NaOH. If it give a blood red coloration, the sample is your primary. If it give a blue coloration, the sample is your secondary. If it does not give any color, that is called tertiary. And in this way, we can identify the given sample of alcohol, whether primary, secondary or tertiary. The best method is Lukar test, next to Victor-Meyer test. Then you come to oxidation and dehydrogenation. Okay, students, these are all about your reaction of alcohols. And let us come to some specific alcohols. The specific alcohols. The specific alcohol that is called methyl alcohol, or what are the uses? That is methyl alcohol. And this methyl alcohol is known as in affection methanol, and it also known as wood spirit. It's called what? Wood spirit. Why it is called wood spirit? Because the methyl alcohol are prepared from destructive distillation of wood. And this methyl alcohol is poisonous in nature because it can affect to the optical nerve and consumption. So the ethyl alcohol generally used for as a solvent, particularly in paint industry, and for the preparation of formaldehyde and formic acid, and it also used in some denature the ethanol. Mean ethyl alcohol denature mean unfit for consumption. Unfit for consumption. Okay, next come to what is the ethyl alcohol. And ethanol is known as ethanol, and ethanol also known as grape alcohol. Because the ethanol generally prepared from the grapes by fermentation. And the ethyl alcohol is widely used for beverage process for consumption. And the variety of ethyl alcohol, that is 95% of ethanol, means aqueous solution of 95% of ethanol is called rectified spirit. You see, you are using spirit, that is called rectified spirit, and rectified spirit containing what? 95% of ethanol. If the ethanol is 99.9% of ethanol, it's called absolute alcohol. And the mixture of ethanol for gasoline, means petrol, this is 50%, and this is also 50%. In presence of little amount of co-solvent, that is called benzene, and that's called power alcohol. This power alcohol used as a fuel, motor fuel. So, particularly ethanol are used, it is also used as the solvent, that is, you can say industrial solvent in various industry. It is used particularly beverage or consumption of the human beings, and it is used for the preparation of acetic acid and acetaldehyde. These are some uses of ethanol. Now come to some conversion. How can you convert the methanol to ethanol? But we little bit will discuss about the conversion. The conversion of methanol to ethanol. The conversion of methanol to ethanol will rise one more carbon atom, that is CH3OH, this CH3CH2OH. So to rise the carbon atom will undergoes reactification. So this became unventilated with red phosphorus plus iodine. It gives CH3I, and this is treated with alcoholic solution of KCN. This became CH3CN. This is reduction. This became CH3, CH2, NH2. You see the CN group reduced to CH2, NH2 group. And this is ventilated with HNO2, that is your nitrous acid. This OH group became what? OH group. The NH2 group became what? This is your ethanol. Starting with methanol, they convert to form ethanol. What about the vice versa? Vice versa means you have to convert this ethanol to methanol. To convert the methanol to ethanol, this is oxidation. It gives CH3, CHCOOH, acetic acid. And this acetic acid, when treated with ammonia and heat, it gives you CH3CONH. This gives you amide. This amide treated with bromine and KOH, aqueous KOH. This one type of reaction is called Hofmann bromamide reaction. Became to form CH3 NH2. This is treated with HNO2. Upon heating, it gives CH3. Do you know the method? It's so many methods. Suppose you heat this one with soda lime. So it gives you methane. Methane and chlorination, it gives methyl chloride. Methyl chloride heated with aqueous KOH, it gives you ethanol. So many methods, so many conversions, so many ways. But the best way is the shortest way. Best way is your shortest way. So many methods you can adapt. For example, another method I can say, another method, that is your you treated with concentrated sulfuric acid at 107 degrees C, it forms ethene. Dehydration gives you ethene. Ethene and ozone laces, reductive ozone laces in presence of zinc dust, it gives you formaldehyde. Formaldehyde reduced with lithium aluminum hydride, it gives you methanol. So many methods, not only one method. Similarly, you can also use, this is your, suppose you want to convert this ethanol, that is CH3OH, this is oxidation, this gives you formaldehyde, and the formaldehyde react with ignite reagent CH3, MgBr, and hydrolysis, it gives you what alcohol? That gives you CH3, CH2OH. This is your ethanol. This is your what? Methanol. So many ways you can convert the one organic compound another organic compound if you know the detail of the partition characteristics. Okay students, this much today. Today we will discuss the oxidation of alcohols, dehydrogenation of alcohols, and oxidation. The primary alcohol gives an aldehyde, secondary alcohol gives a ketone, possesses the same number carbon atom, and the tertiary alcohol doesn't oxidize so easily. And dehydration means the sample of the alcohol when passed over red hot copper. The primary alcohol gives an aldehyde, the secondary alcohol gives a ketone, and the tertiary alcohol is isoalkane. And the sample of the alcohol, the primary, secondary, tertiary alcohol can be identified by the two methods. One is called Lookup test, one is called Victor-Merc test. In Victor-Merc test, by the action of the Victor-Merc reagents, the primary alcohol gives your blood red coloration, the secondary alcohol gives blue coloration, and the tertiary alcohol does not give any coloration. Next come to some uses of methanol and ethanol. And there is a method to conversion of methanol to ethanol, ethanol to methanol, that is methanol to ethanol, and vice versa. We can go through so many methods. Okay students, this much today. Thank you.